Hey Precalc, today's lesson is one of the most valuable I teach, and yet it will not be on a summative because it is not actually addressing a standard. But I hope you'll all watch it and try this out because it is such a useful application that is on your calculator. So today what we're going to learn about is a button on your calculator right here next to math. It says apps. Okay, right next to math it says apps, and you're going to push that apps button, and on every Texas Instruments calculator for years and years there's been an app as number one that is called finance. And under the finance menu, if you push enter, you can solve for any of these things, but the coolest one is this very first one. It's the time value money solver. It means you can put your cursor anywhere and solve for any of those things. So that's what we're going to use. So it's apps and then enter twice to get here. Now we need to talk about what all these stand for. So I'm going to go to the next slide here. Now I put this in because I like everybody to see this. This is the formula you would need to use to calculate the future value of what's called an annuity, which is an account that you continue to add money to, okay? I'm saving for my retirement, and so I put away a certain amount of money out of every paycheck into an account. This is if that account were simply drawing interest, okay? So I'm adding to it every month. If I want to know the future value, this is the complicated, nasty formula I would have to use, and on my calculator I need a million pairs of parentheses. But because of this app called the Time Value of Money Solver, okay, you don't have to do that. So again, to get there, it's under the app button. You hit 1 for finance. It is the TVM solver right at the top, okay? Now this is what it stands for. N, is number of payment periods, and that is the number of payments, okay? So if you decide not to make payments, it's still how many times it's compounding over a course of something, so just be careful. And it is usually something times 12, like 3 times 12 for 3 years worth of payments or whatever. And you can actually type right there, and I'll show you that in a minute. I is interest, and you do not move the decimal over. You put the actual percent in there. PV stands for present value, which if you borrow money, it's the amount of your loan. If you are starting an annuity, it's 0 because you're starting with nothing and you're going to put in payments. The PMT stands for payment amount, and if you're doing an annuity, you're going to put a number in there, how much you want to save every month. But you're also going to use that spot to calculate your house payment or your car payment when we do those kind of questions. FV is future value, and the future value at the end of a loan, you want to pay it off to 0. The future value when you're borrowing, or when you're putting money away for retirement, the future value is what you want to calculate, how much you're going to have when you retire. Payments per year and compoundings per year can change. For all the questions I've chosen to do this year, we're just going to leave those 12 and 12 because I didn't want to get too fancy with stuff. And this at the end, the bottom here where it says payment end of the month or beginning of the month, it defaults to end of the month, and we're going to leave it there, please. If you do beginning, you'll get different answers. Okay. Now, our first example says an investor pays $600 quarterly into an annuity. Okay, so this one is not going to be 12 and 12 necessarily. The annuity earns 7.24% annual interest. What will be the value of the annuity after 15 years? So N is the number of payments. Quarterly means 4 times a year for 15 years. this investor is going to put this money in. And we get to just type 4 times 15 in that spot. You don't have to, it's 60, but you don't have to put 60. You can just type 4 times 15 and it'll take care of it. The interest is 7.24 and we don't move the decimal over. The present value is nothing until we start making payments of $600. What'll be the value of the annuity after 15 years? So the future value is what we want to find. So we're going to put our little blinking cursor in this spot and then do what's called solve for it. The payments per... All right, guys, sorry I was interrupted there. My son came upstairs and didn't know I was recording. So I'm not sure where I left off, but this is quarterly. So we're going to do 4 times per year and 4 compoundings per year. Again, I think I just mentioned everything else we do is 12 on this packet, I think. But anyway, so we're going to pull out the calculator. We get to this spot. Again, it was apps right up here. Enter, enter, and then we're going to put in, literally we can type 4 times 15. Enter and it'll go down. It was 7.24. Enter. Present value is 0. Payment is what we're trying, or I'm sorry, the payment was $600. So I'm going to go ahead and arrow down or enter and put in 600 here. Now, go past future value down and make both of these 4 and 4. Now, when we go back up here to future value, this is what we're trying to calculate. It doesn't matter if it has a number here, it's going to overwrite this with our calculation. I don't know about you guys, but I always wondered why it said solve down here. Well, this is the day you finally get to use that solve feature. We are going to say alpha, while we are in this box, okay, the future value, we're going to say alpha, enter, and it's going to come up with a number. Now, I need to explain why it's negative. The reason it's negative is if you consider giving the bank $600 as positive, then this is the bank giving you back $64,000 after 15 years. These have to have opposite signs, and it doesn't matter which way you do it. If you had put negative 600 here, and then gone down to this spot and done alpha enter, remember it's not second enter, it's alpha enter, the sign would be positive. It just means one way is the bank getting your money and one way is what the bank owes you back. It's the only way the calculator can do it is for it to have opposite signs. So this comes out 64,102.91. Is what you would have from this annuity after 15 years. Now, just because I like this to make sense to you, I want you to show you what happened. You put $600 in there 4 times a year for 15 years. That's actually 36,000, I believe. Let's see if I'm right. Go back, quit. 600 times 4 payments a year times 15 years. Yeah, you gave the bank $36,000. All of the rest of this is interest that it earned. Okay? Now, we'll go to the next slide. This takes you through those steps. If you missed anything, follow along here. We did not use this future value business. We just did solve. Okay, so it was, we put the cursor here, and then we did alpha, solve, or enter. All right, now this is a payment question. It says, when taking out a loan for a large purchase like a home or car, consumers are typically concerned with how much their monthly payment will be. While the exponential function below can be used to determine the monthly payment of either a home or a car, okay, any kind of loan where you're making payments. Again, super complicated, lots of things to plug in. You'd need a ton of parentheses if you were trying to do this on the calculator. So we're going to use the solver. Now, it does say over here, when you make a down payment, the amount is subtracted from the present value before anything else is calculated. So it says we're going to borrow $170,000 from the bank to purchase a home. The 30-year loan has an annual interest rate of 4.5%. Calculate your monthly payment and the amount paid after 30 years. So what do we know? Well, we know we're going to make monthly payments for 30 years. So we can type that there. I'm not a big fan of this red. Let me change this. The interest is 4.5 and we don't move anything over. The present value of the loan, we have borrowed $170,000. We can put it in as positive or negative. The opposite sign will be on our payment. So if we put this as positive, this is going to come out negative. It's just a sign to indicate one way is the money going in, one way is coming out. It doesn't matter. You don't indicate the sign when you write your answer over here. Calculate your monthly payment. Okay, the payment is what we're trying to find. So this is where we're going to put our cursor. After we fill the rest in, the future value of a loan, okay? This is because it's a loan that we want to pay off after 30 years. The payments per year, we're making monthly payments, compounding's the same, okay? So I'm going to go back to the app. So it's, sorry, wrong button. Apps. Oh, that was good. Let's try again. Apps, enter, enter. It was 30 times 12 here. It was 4.5% here. Present value, 170,000 we're borrowing. We want to figure out what the payment's going to be. You can clear this out, but it doesn't matter. You're going to put some of your cursor there in a minute, but we have to go down. Okay, they want us to put something there, so I'm going to put 0. The future value, you have to make 0 before you do this. Otherwise, it's not going to calculate the payment correctly. And then it's monthly interest and monthly payments. So we're going to put that 12 and 12. Now go back up here. Put your cursor at the payment. That's where we want it to sit. Doesn't matter if there's a number there or not. We're going to overwrite it by doing alpha, enter, and our payment would be $861.37 if we round to the nearest penny. Now, we want to figure out how much money this actually gave the bank. How much did we actually pay for this house? If we do $861.37 every month for 30 years, we will have paid a total, in order to pay our house off, $861.37 times 12 a year would be $10,000 a year. For 30 years, we would have paid 310,093.20. So $310,000 total on a $170,000 loan. I got to tell you guys, when you borrow the money longer, you end up paying more, and the interest rate has significant difference on that as well. So we're going to look at a few more questions here. So they put this all in, shows how they got this, the payment. Okay, we did a little using the solver, but that's the same thing. And you just ignore the negative. It's one way or the other is going to turn out negative, and that's not what we want to include as our answer. Determine the payment on a loan of $6,800. So this is our present value we're going to borrow, given the interest rate, I is going to be 3.8, compounded monthly, so we're going to use compoundings per year and payments per year to be 12. Length of the loan is 5 years, so N is going to be 12 times 5. Now, when I do these, I usually just write it all down here so that I can keep track of what I did, because if this were the good old days, I would be giving partial credit based on your work, and this would be considered your work. The future value, because it's a loan, okay, you have to pay it off at the end. So we're trying to get the future value down to 0. We're trying to determine the payment, so that's where we're going to put our cursor. I is 3.8. I know these aren't in order, guys. I'm sorry. Payments per year and compoundings per year. I don't know what order they're on the screen, so I'm just going with it. Again, apps, enter, enter. 12 times, I already forgot, we were borrowing this for 5 years, okay? So that's a 60, but it calculates it for us. Interest was 3.8. The present value of the loan, maybe I'll put it in negative this time, it doesn't matter. Put it in negative or positive, it just means the payment is going to be a different sign. Future value we want to be 0, payments per year, compoundings per year. Now, I did not clear this old answer out here, you certainly can. But either way, it's going to overwrite. When you do alpha, enter, it's going to find the new amount. Now remember, I made this negative, so this time it turned out positive. But it's the same answer. If you delete the negative here and you go down and solve, it just makes this one negative. So 124.62 is our payment. So that seems like a pretty reasonable payment, right? If you borrow $6,800 for a car and your payment a month is $124.62. But I do want to show you that when you take $124.62, because you borrowed this for a long time, 5 years at monthly payments, oh my goodness, what happened there? 12 times 5 times 124.62. I must have, still something sticking here. There we go. You've paid back $7,000. Now, that's not horrible to borrow that money for 5 years, okay? You paid back, what, an extra $600, almost $700? So to have a car to drive for 5 years could definitely be worth that in interest. All right, if you deposit, so this is an annuity question. So this means your payment you're putting in every month is $25. Starting today, so your present value is 0. How much will you save after doing this for 40 years? So N is going to be 40 times 12. I is 6%. And compounded monthly just means you're going to do 12 and 12 down at the bottom there. So we are trying to figure out the future value. All right. So I'm not going to rewrite it this time. I'm just going to go apps, enter, enter, 40 times 12. The interest was 6%. I'm only putting away $25. Oops, sorry, present value is 0. My payment is $25 every month. I'm just throwing 25 bucks into this account. So I want to know what it'll grow to in 40 years. So my future value is what I'm trying to figure out. And I do alpha enter, and it says I'll have almost $50,000. So 4, 9, 7, 8, 7, 27. And again, it looks like there's something under there, but that's just because it's blinking. Okay. So I'm almost $50,000 is my future value. If you wanted to know how much of that you originally put in You could say 40 years of monthly payments of $25. So 12,000 of that is my money. All the rest of that is interest. That's why it makes so much sense to start saving when you're young. And I didn't do a very good job of that, so I won't be teaching for a while yet. All right, this is a house payment question. You know what? Maybe I'm going to pause the video. Nah, I'm just going to skip this one, and I'll come back and you guys try it, and then I'll put it in the notes, okay? Because we've done a house payment one. This is a great question. This says, suppose you know, this is example 5, suppose you know you can only afford a $300 a month loan for a car payment. So your payment, say I can afford $300 a month. And somehow you got the credit union to quote you an interest rate of 2.5%, which is really low. And you want to pay it off before you leave for college or something. So you do 3 times 12 or 36 payments. Okay, so the question is, you want the future value at the end of this to be down to 0. So what is the present value that you can borrow? And we use 12 and 12. Okay, so this time we're kind of trying to work backwards. Apps, enter, enter. I want to make a 3-year loan, so 3 times 12 at 2.5% interest. I want to know how much I can borrow, so I'm going to come back to present value. If the payment I can afford is $300, and at the end of that 3 years, I want the future value to be 0, and these are 12 and 12. So I go back up here to the present value, and I do alpha enter, and it says I can borrow about $10,394.51. Now, I don't know what you know about buying a car, but this does not mean you should go look for a $10,000 car, because there's all kinds of fees added on and you'll end up owing more than this. But that's how we set that up. And so you maybe can go looking for, a $9,000 car and you'll have a little money to play. All right. This is a great question that I put on here to educate you about mortgage. It says, what is the difference in monthly payment on a $150,000 home loan at 7% interest compounded monthly if it's borrowed for 20 years or 30 years? So for this one, we're going to do n equals 20 times 12. And for this one, we're going to do n equals 30 times 12. For both of them, we're going to do 7%. And we're going to do, the present value is 150,000. And the future value is 0. Okay, we want to figure out what the difference in the payment is, and then we're going to figure out how that saves us money. So if we go up here, if we borrow for 20 years at 7%, oops, this was supposed to be 20 times 12. I didn't type that, did I? And we're going to borrow 150,000. Whoa, it's like it's sticking on me today. Okay. We're going to figure out what the payment is in a minute, but the future value should be 0 and these should be 12 and 12. So I'm going to come back up here to the payment and do alpha enter. Now my payment is pretty big. It's $1,162.95. Okay. Just in case anybody doesn't get that, I'll slide this down here so you can look and it'll be on the notes. All right. For this one, we're going to change it to 30 years. So the only thing we change is the number of payments. We're going to change this to 30 times 12. And that's going to lower our payment because it's going to stretch it out. We're leaving this 7 and 150,000, 0, 12, and 12. But the payment, when we do second enter, alpha enter, not second, for the payment, it is only under $1,000. It's $997.95 a month. Okay. But if you look, guys, that's less, a little over $250 maybe. Okay, the difference. So I want to talk about the difference in what happens on the total amount. So the total you pay, if you are at, 1162.95, was that what it was? I can't see. Times 20 years of monthly payments, so 12, you paid $279, $279,108 in total for your $150,000 house. Now that seems like a lot, but this is even worse. If you paid $997.95 times 30 years of monthly payments, you paid $359,262 for your house. Let's see if I can put this down at the bottom. All right, so it says, how much did you save if you didn't stretch the loan out for that extra 10 years? Okay, if you somehow scraped together that extra $265 or whatever it was to make up the difference in those, and I'm probably subtracting wrong in my head, but so if we subtract these two numbers, we saved $80,154. And that's all interest, okay, on a $150,000 house by paying it off in 20 years instead of 30 years. Now, it was bigger payments, and sometimes you can't do that, but it does make a huge difference in the amount you pay. All right, so there are going to be 6 application problems for you to try using this app, and that's it for today's practice. This is kind of a bonus day, okay? I'm going to finish this number 4 in the notes. And so you can try that one just to check before you go back and do the practice. All right, that's it. 22-minute video.